Hi, my name is Sille Larsen and I'm the Senior Water Resources Engineer with Vermont Department of Health. I work in the drinking water program and we assist the people in Vermont drinking water from a private source of water, such as a well or spring, and we help answer questions about water testing, sources of contaminants, and treatment. Today I'm going to talk about private water systems in particular and the responsibilities of town health officers. So just to give you a bit of background to drinking water use in Vermont, as many of you know, the population is approximately 624,000. Of those, 70% drink water from a public water system and the remaining 30% drink water from a private system, typically being a drilled well, a duct well, or a spring. Going through the data from the Health Department laboratory, we find that approximately 5 to 11% of people drinking water from a private source have had the water tested, so not a whole lot of people. And of those available test results, we know that more than 10% have at least one contaminant above a level of concern. So just to give you some background on the difference between a private and a public water system. A private system is defined as a water system serving less than 25 people or 15 connections. Private water systems are widely unregulated, relying on the homeowner to be aware, willing, and capable to monitor, improve, and maintain the safety of their drinking water. A public water system, on the other hand, is regulated by Vermont Department of Environmental Conservation and serves 25 people or more or 15 connections or more. And it's maintained and monitored by the system's operator and Vermont Department of Environmental Conservation. So here is a list of the typical contaminants we find in drinking water. The list of naturally occurring contaminants is long, and here are just a few to highlight, such as fluoride, uranium, radon, iron, arsenic, and manganese. These contaminants are all naturally occurring in the rock and soil. Bacteria like total coliform and E. coli might end up in your water if your well or aquifer is compromised, meaning contaminants can find their way into the system through, for example, cracks in the well cap or from nearby pollution traveling with groundwater into your well. Lead can get into drinking water as the water moves through lead or galvanized iron pipes and fittings, and or lead solder or brass or chrome fixtures. Nitrate contamination of water usually comes from fertilized agricultural fields, septic leachate, or manure or compost piles that are located too close to wells. Use of pesticides could also result in drinking water contamination, primarily in shallow wells. And finally, your well could also become contaminated with man-made chemicals such as PCE and TCE used in industry as solvents, and PFOA used for several industrial applications such as textiles and cookware. So why is it important to be aware of all these chemicals in drinking water? For the most part, you can't see, taste, or smell the contaminants, and if they're present, they might result in adverse health effects either short-term but primarily long-term. The only way to know what's in your water is to have it tested. The picture to the right shows the water testing kit that the health department recommends to everyone drinking water from a private source. It consists of a 1 liter bottle for inorganic chemicals, a 1 liter bottle for gross alpha, a 250 milliliter bottle for first draw lead, and a 100 milliliter bottle for bacteria. Events like floods or droughts can also result in drinking water contamination. During and after flooding, water can become contaminated with microorganisms such as bacteria from sewage, or heating oil or chemicals from nearby tanks, or agricultural or industrial waste. People with private drinking water wells in flooded areas should assume their water is contaminated. The water should be tested for bacteria as a minimum and chemicals if there are signs such as a sheen or odor to the water. Until a water test confirms that the water is safe, get water from a known safe source or boil your water for 1 minute to use for drinking and cooking. In events of flooding, the health department might offer free water testing. You can contact the drinking water program for details in case of flooding. Vermont typically has enough rainfall, but some years can be dry and can lead to drought. Drought can cause groundwater levels to lower and in some cases result in wells running dry. Test your water if you notice changes in your water like cloudiness, color, or smell. The Department of Health Laboratory is responsible for analyzing a big proportion of private wells in Vermont. Using the water quality data allows us to map the different contaminants to identify areas of concern. Uranium is one of the naturally occurring contaminants we find in Vermont groundwater. This map here shows the percent of test results with uranium levels above the maximum contamination level of 20 micrograms per liter. Green on the map indicates that none of the test results had levels of uranium above MCL, the maximum contamination level. And dark orange is showing towns with 12 to 20% of wells with uranium levels above MCL of 20 micrograms per liter. If less than 20 wells have been sampled from within a town, the data is suppressed due to lack of statistical power and marked with white on the map. Uranium is just one of many radionuclides we find in bedrock. Uranium is the parent nuclide, and some examples of progenies are radium and radon. Even though we can create maps to show areas of concern for drinking water contaminants, we do see big variations in water chemistry within a small area. And so the main message for people on private water is to have the water tested. For example, Vermont Geological Survey did a study in Charlotte in the summer of 2009, testing 27 bedrock wells for metals and non-metals such as fluoride. On the map in green are displayed the fluoride test results from the 2009 study. None of the wells showed levels of fluoride above the maximum contamination level of 4 milligrams per liter. But if we compare those results with the results from the Health Department Water Quality Database, shown in pink on the map, we see that Charlotte has quite a few wells with levels of fluoride above the primary MCL, the 4 milligrams per liter. So it's very easy to miss the wells with problems, and so the only way to know is to test the water. So really everyone, me, you, everyone on private water should have the water tested. It is the only way to know what's in the water. If you pay a water bill or receive town water, the source water is tested and treated by the operators. However, if you live in an old house, your own plumbing might include lead components resulting in lead contamination. And so we recommend that people on public water have their water tested using a first draw lead test. The general water testing recommendations from the health department is total coliform bacteria test every year, inorganic chemical testing including 11 parameters every 5 years, and gross alpha radiation screening testing every 5 years. The 3 kits are called Kit A, C, and RA with the health department laboratory. A law that became effective in 2019 now requires that all landowners of single-family residences who install a new groundwater source for drinking water, for example, a new drilled well, a new shallow well, or new driven well point, or a new spring, or who deepen an existing groundwater source, test the water before using it. The requirement is in the Department of Environmental Conservation's wastewater system and potable water supply rules. You can find the rules by following the link on the slide. The required tests are called Kit A, Kit ID, Kit RA, and Lead First Draw with the Health Department laboratory. People can order the kits by calling the customer service at the lab. The lab can either send the kit or have people pick it up in Colchester, where the lab is located. People can also use a certified private lab. They offer the same types of tests as the health department laboratory. For a list of all the Vermont certified drinking water labs, check out the link below. So far, I've been talking about general information about private water in Vermont, but what is expected of you, the town health officer, when you receive a complaint from a tenant about water quality issues? Your role is well described in the Town Health Officer Manual on page 16 and 17, but in short, your role is to inspect the rental property, or in this case, sample the water, and document your findings. Specifically for water supply issues, the process involves 5 steps. Step 1, receiving the complaint. So after you receive a complaint from a tenant about water quality issues, you should call the Vermont Department of Health Drinking Water Program. Together, we can assess the situation and come up with a plan. We then ask of you to collect a water sample from the home and return the sample to the lab. Once you receive the water testing results, you can call the drinking water engineer at the health department to discuss the results and next steps. And finally, you need to talk to tenants and landlords about the results and next steps. So again, to reiterate, step 1, usually this process is initiated by the tenant calling the town health officer to complain about the drinking water quality. In cases where the tenant doesn't want to ask their landlord to test the water, or the landlord refuses, the health department offers free test kits to the town health officer for you to go and test the water. It's important to mention that according to the Rental Housing Health Code, it's the landlord's responsibility to provide potable water to tenants. So if the tenant can work out testing with their landlord, then the landlord should pay for the test kits. I won't go through all this text. You can find the language in the Town Health Officer Manual on page 22, but I just wanted to draw your attention to the requirements listed. Step 2. When you receive a complaint from a tenant, we want you to call the drinking water program with the health department. Depending on the issues being discussed, we may recommend additional testing besides the regularly recommended testing of bacteria, inorganic chemicals, and radionuclides. The health department will email the laboratory customer service to request the recommended kits be set aside for pickup by you or mailed to you. Step 3. Once you receive the kit, you should arrange a time to go to the residence to sample the water. You should be sampling the water from the kitchen faucet if that is the faucet the tenant is using for drinking and cooking, which is the normal faucet to use. Sampling instructions are included in the sampling kits, and a video on sampling is provided following the link on the slide. When you sample the water, remember to write your name and contact information on the form. Also state which town you're from and that you're a town health officer. That way the results will be mailed to you. Once you receive the results from the laboratory, you can contact one of the drinking water engineers with the health department to discuss the results of the test. Here's an example of the report from the analysis of Kit C, the inorganic chemicals. In the upper right corner, you have the unique number used to identify the test. Further down in the first column, you find the analytes, here fluoride, chloride, nitrite, and nitrate. Second column shows the final result, meaning the level of a contaminant found in the water. If there's a less than sign shown, it means that the level of a contaminant was below the reporting level. The third column shows the units measured in milligrams per liter. Fourth column shows the limit, meaning the maximum allowable level of a contaminant in drinking water based on federal and state standards. The fifth column indicates whether the analyte has a maximum contamination level, a secondary maximum contamination level, or a Vermont Health Advisory level. If the final result of a contaminant is above the limit, the landlord is required to treat the water. You can find more information about interpretation and treatment on our website if you follow the links on the slide. Step 5. Once we've discussed the water testing results and next steps, you need to talk to the tenant about the water test results. It's the responsibility of the landlord to supply potable water. So if a contaminant exceeds the maximum contamination level, the MCL, or the Vermont Health Advisory level, the VHA, the water must be treated for those contaminants. Treatment options could include shock chlorination, or a treatment system unit installed where the water comes into the home, or a new source of water. If the tenant or landlord wishes to discuss the results further, they can call the drinking water engineer listed in step 2. I'm not going to walk you through treatment of all contaminants, but I thought I would mention the most common water quality issues, the presence of bacteria in water. If coliform bacteria are present, you should work with the landlord to inspect the well and water system and make repairs. Once repairs are made, the well will need to be disinfected using chlorine. Retest the water 2 to 3 days after the smell of chlorine is gone. If the well still has a bacterial contamination, the landlord can have the well professionally inspected by well contractor. This is generally recommended every 10 years. And finally, the landlord can install permanent treatment such as a UV light. Here are some examples of what to look for when inspecting a well. This first image is an example of a well in good condition. Next are some examples of wells in bad condition. The first picture shows a well with the electrical conduit sealed with electrical tape. Tape is not a permanent or reliable repair, and you should instead permanently repair the conduit with a new plastic fitting. Second is a well too low to the ground. You can talk to a well driller about extending the casing 18 inches above ground. This third image shows a cracked well cap. The cap will no longer provide a watertight and sanitary seal, and so the landlord should replace the well cap. This last image is an example of frost heaving. The landlord should instead install a frost sleeve on the conduit or bury the conduit deeper to below the frost line to minimize heaving. You can find a little slideshow with these images of good and bad wells and how to fix it if you follow the link at the bottom of the slide. Here are some examples of duct welds. This first picture shows roots growing in between the tiles. The roots can provide a direct pathway for surface water to enter the well and contaminate the water. The next picture is showing a cracked concrete tile, and small insects or animals may be able to get into the well and again contaminate the water. Again, here you see roots, and if you look carefully between the lower tiles, you can see a little frog sticking out. This well, just like the other two welds, should be cased with a watertight material and a cement grout or bentonite clay sealant poured along the outside of the casing to the top of the well to provide a sanitary seal. If the well you're inspecting is a duct well and the bacterial test is positive, the drinking water program recommends that the landlord installs a UV light where the water enters the house. Shock chlorinating the water is just not a permanent fix. As a final remark, you can find a lot of information about drinking water contaminants, health concerns, and treatment options on our website, healthvermont.gov/water or healthvermont.gov/water-contaminants. You can find links to water treatment specialists, certified well drillers, and information about financial assistance to eligible Vermonters. If you have any additional questions, you're more than welcome to call the Drinking Water Program. Thank you for listening.